So this is the new DC-CT sensor. So what's special about it?
Yeah, the main features for this sensor is its miniature size to capture the currents in ranges of up to 1000 amps. It's a remarkable bandwidth of up to 500 kilohertz, and also the lower power consumption in comparison to the other zero-flux transducer. That makes it very suitable for the in-vehicle current measurements, so in e-mobility, as well as to the regular power applications like network grid, power quality analysis, the other small and high current amplitudes of different applications.
So this has an accuracy of about plus or minus 0.02%. But can I, in Devisoft X, put a range of like 100 amps so that I have a plus or minus of 0.02 amperes? Now, in a 1000 amp range,
Yes.
it has a plus or minus of 200 milliamps.
Yes.
If I set the range to 100 amperes,
Yes.
I should be able to measure with the plus or minus.
Okay. Yeah. The thing that we are discussing here, the accuracy of the sensor itself. So these calculations that we provide are the accuracy of the sensor. However, if you connect this to the host amplifier, to the host device, this can then also add the accuracy of that host amplifier to it. In order to make the most optimal value of the range of the host amplifier, this is then the best way to, let's say, optimize the accuracy of the whole chain. So sensor plus the readout data acquisition system.
Yeah. And to power it, we need this power supply here.
Yes, so it works with a plus minus 15 volts excitation sensor supply, but we provide, as the Devisoft, provide the power MCTS, so the power supply for 4 sensors, mainly for the applications like DC plus 3-phase measurement, so it fits perfectly for the power train analysis to capture the 4 currents at once, and then from that power supply the signal is routed to the host amplifier.
Yeah, because the single series is too weak to power one of these.
Yes, exactly. So the maximum excitation from the, for instance, low voltage channel is 2 watts, but this is a 5 watt, approximately 5 watt power consumption of this sensor.
Okay. And so having this is the only way to power it?
No, I mean you can power it from the otherwise. So it's this is just the convenient, let's say, suitable system where it's easy to connect or easy to use, and we provide it as a whole solution. But it doesn't have to be particularly this power supply. So you can power it directly from it. Actually, we are even working on a solution that will be able to power and acquire then the analog data from the sensor at once.
Interesting. And so you would want to make like an upgrade to the series so that it has a more powerful power supply?
Actually, it has a, let's say, a trade-off. So in that case, series is still intended for the high bandwidth measurements, so for the especially with the XHS, where we can reach the 5 megahertz bandwidth with the analog input. That particular is intended for the high power supply option for the sensor. Yes.
Okay.